geotechnical engineering or soil mechanics, we're going to solve a specific problem involving the particle size distribution resulting from a sieve analysis. First, before we understand further kung paano ba mag-solve ng mga particle size distribution, kailangan natin intindihin at unawain yung table na nandito sa screen na kung saan ito yung mga limits ng mga iba't ibang mga organization depende kung ito by gravel, sand, silt, or clay. Ito sa MIT, US Department of Agriculture, AASHTO, at saka sa USCS. So kailangan kabisado natin yung mga parameters na ito. For a specific problem, so problem number 1, the following are the results from a sieve analysis. Make the necessary calculations and draw the particle size distribution curve. So, kung makikita natin sa problem na ito, given in terms of size ng sieve na ginamit natin, number 4, number 10, hanggang sa pan, mass of the soil retained in terms of grams, ito daw yung mga timbang na mga soil na natira or nag-retain dun sa mga sieve natin. Pinapakompute yung D60, D30, or D10 or ito yung mga diameter ng specified percentage finer. Take note, finer. Uniformity coefficient, CC, uniformity coefficient or CU at saka coefficient of gradation na CC. Okay, determine the percentage finer that the sieve and plot the particle size distribution curve. Okay, so bago tayo mag-solve ng problem, tingnan muna natin yung mga given. So, makikita natin yung sieve size. So, kung kailangan kasi natin is naka-metric. So, meron tayong equivalent sizes na mga sieve natin in terms sa metric na given naman siya. There's no need to memorize. Okay? Tapos, tingnan natin kung ano ba yung unit ng ating mass. Kasi dito natin makukuha yung percentage finer na natira or nag-retain sa ating sieve. So, sa solution, na-tabulate na natin yung mga sagot. So, isa-isahin na lang natin yung kung paano natin siya sinolve. Okay? So, sa sieve size number, which is ito yung given initially kanina, yung sieve size number at saka yung mass retained. So, yung opening natin, so wala to, single P lang. So, ito yung kanyang equivalent size in terms of millimeter. Same thing din dito sa number 10, which is 2 mm, number 20 is 0.85, and so on, which is 200 is 0.075 millimeter yung kanyang opening. So, very important ito kasi isa ito sa mga coordinate natin mamaya sa pagplot ng particle size distribution curve. Next, mass retained. So, yung gagawin lang natin dito initially is kailangan natin siyang kuhanin ng total. So, kapag pinag-add natin yung 0 hanggang 31.2, makakakuha tayo ng 450 grams. Okay? After that, next step naman natin is kuhanin natin yung cumulative mass retained in terms of grams pa din. So, kapag nakita nyo yung word na cumulative, ibig sabihin, it is the previous plus present para makuha natin yung actual. Or yung before, tapos during, para makuha natin yung actual. So, for this first value, wala pa tayong before. So, i-retain muna natin C0 dito sa ating cumulative mass retained. Next, dito naman sa pangalawa, that is before. Okay, before plus present equal siya sa ating actual. So, meron siyang pattern. Okay, so 0 plus 21.6, that is 21.6. This one naman, before 21.6 plus 49.5 equal siya sa 71.1. Next, 71.1 plus 102.6, makakuha tayo ng 173.7. So, may pattern yung pag-compute natin sa cumulative mass retained. So on and so forth. So 41.8 for the last value plus 31.2, that is 450 grams. So isa sa mga checking para malaman natin kung tama yung ating cumulative mass retained if yung last value natin is equal siya sa summation ng total mass retained natin. So yung last value should be equal to the total value pag cumulative mass retained yung pinag-uusapan natin. Next, percentage finer. So ito yung isa sa mga coordinates natin na kailangan sinasolve. Kumbaga ito yung goal natin, kaya tayo nag-compute ng mga mass retained, cumulative, etc. Titignan natin yung kanilang percentage finer. Okay? So assuming that this value is the summation of the entire result from a sieve analysis and cumulative mass retained, assume that's denoted as pangalanan natin na Y. Okay? Para pag makuha natin yung Y natin dito or percentage finer, let's say this is Z. Z is equals to summation ng entire mass minus Y, or in this case Y1, itong value na to, Y2, Y1, Y2, etc. Okay, kumbaga varies ito. Tapos ito naman summation ng mass din. So since percentage yung pinag-usapan natin, multiply natin yan ng 100%. Okay, for Y1 or first variable, 450 minus 0 divided by 40 times 100, equivalent yan sa 100%. Next, again, 450 for the mass total minus 21.6 for our second Y over 450 times 100, makakakuha tayo ng 95.2 na percentage finer, and so on and so forth. So ganun sinusolve yung percentage finer. So sa pagpa-plot, ito yung kailangan natin, ito yung sa X value, at ito naman yung sa Y coordinate. X coordinate. Okay? So after natin ma-identify yung mga coordinates natin, so i-simplify natin siya. Sa opening na 4.75, meron siyang percentage finer na 100%, 2 mm na 95.2, 0.85 na 84.2, 0.425 mm na meron 61.4 percentage finer, 0.250 mm meron tayong 41.60 percentage finer, 0.150 para sa 20.36% finer, at saka 0.075 mm para sa 6.93% finer. So ito yung mga X coordinate natin. Ito naman yung Y coordinate. Okay? To continue, so ipa-plot na ngayon natin yung mga na-solve natin na mga coordinates. So ito yung graph na kung saan magpapakita ng mga diameter with their corresponding finer. So sabi ko kanina, ito yung mga percents na to, ito yung percentage pa, ito yung Y coordinate, Ito naman yung x coordinate. Kung mapapansin ninyo, yung scale natin is hindi siya para-parehas ng increment. Okay, kumbaga ito yung tinatawag natin ng logarithmic scale. Okay, so kung mapapansin niyo yung mga value natin, ito yung mga coordinates or mga diameter natin in terms of millimeter. Okay, so pagbasa dito from 0.01 papuntang 1, so by 10 pa din ito. This is 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09 hanggang 0.1. Tapos ganun pa din 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. Same thing din dito. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So kumbaga by 10 pa din siya. Kumbaga nagbabago lang yung kanyang parang significant value or yung kanyang decimal. So para makompute natin yung diameter on a specific percentage finer, magpa-plot lang tayo ng line. For example, D60. Yung D60 na to, itong line na to, itong D60 na to, ano yung value na to? Itong point na to. Ano yung value niya? Tapos, project natin siya dito sa value natin dito. Okay? Kumbaga, projection lang ito sa value na to. Tapos, ano yung kanyang diameter? Okay? So, kung diameter 60 tayo, ano yung value na to? So, if this is 0.1, and we can say this is 0.2, 0.3, 0.4. Okay? So, 0.4 tapos somehow papunta na siya sa 0.41 pero ano siya, medyo alanganin or pwede natin sabihin na 0.41. D60 0.41. Next, D30. This is 40, this is 30%. Kumbaga, what is the diameter at the 30% finer? So if we project this, tapos ano daw yung kanyang equivalent diameter? So in this case, medyo malapit na siya sa 2. Okay, kumbaga tansyahan lang, tatansyahin natin kung ano yung magiging value. Okay, this is 30 per project. So approximately we can say that the D30 is equals to 0.189 or 185 if ano. What is this value? Kumbaga, scale talaga natin siya. Yun lang yung medyo sa pagpa-plot. So, kailangan naka-scale yung mga ginagawa natin. Straight edge. Next, for D10, ganun din. If this is 20, this is 10. So, pa-project natin. Kailangan straight edge. Kung saan nag-intersect yung ating value o yung ating graph, medyo tabingi lang. So we can say that D10 is equals to 0.88 or 0.9 in some cases. Ba ito? 0.09. So, yun yung pag-determine ng mga diameter at the specific finer. Depende kung anong type of the diameter at the specific percentage finer. Okay, so first procedure yung gagamitin natin yung itong scale na to. So, magiging catch lang dito is kailangan at least scaled yung ating value. Kasi ipoproject natin siya dito sa graph. Okay, so D60, 41, D30 is 0.189, D10 is 0.88. Base dito sa particle size distribution curve natin. So, magkakaroon tayo ng variation or mga minor discrepancies, though it is still considerable or okay pa yun. Okay? Kasi merong ibang instances na yung iba is 0.19 instead of 0.189, 0.09 yung iba instead of 0.088 and so on. Second procedure is gagamit tayo ng interpolation. Okay. Kung babalikan natin ito 4.7 ito ay finer. Diba sabi natin the diameter, it is the opening at a percentage finer. So kung 0.6 D60 yung hinahanap natin, D60, ibig sabihin between this value makahanap natin yung D60. Tama. Diameter at a 60% finer. Kasi between 41 to 61.40, doon natin mahanap si 60% finer. Same thing sa D30 na between siya na 20.36 to 41.60, D30. And D10, 66.93 to 20.36, dito natin makikita yung D10. Hanapin natin yung kanilang diameter base sa mga percentage finer natin. Okay? Since logarithm yan, so itong mga value na to, yung x, kasi kung makikita ninyo, yung x coordinate natin, yung mga iba't ibang mga increments. Sabihin ito yung mga nakalog or logarithm. So, kailangan yung pag-interpolate natin, kailangan naka-logarithm din yung ating value. So, for example, meron tayong log 1 or gawin na natin sa D60. So, for D60, diba yung first value natin is 0.425 at saka 0.250. Between this value, mahanap natin yung diameter at the 60% finer. Okay? So, D60 logarithm, since yung x value or yung diameter, yung mga may logarithmic scale, so logarithm at 0.425 minus logarithm at 0.250 divided by 61.4, ito yung kanilang percentage finer, minus 41.60. Ito yun. Ito yung mga value na yan. Tapos interpolate natin logarithm of 0.425 minus logarithm of the diameter at the 60% finer. 61.40 minus, since percentage finder pinag-usapan natin dito, hinahanap natin yung pang 60, compute natin yung 60% finder. Kapag sinip solve natin yan, D60 is equivalent to 0.409, which is roughly equivalent sa ating pagpa-plot. Next, for the D30, ito mga value naman na to yung tinitingnan natin between this 0.15 and 250. Doon natin mahahanap yung diameter at the 30% finer. Okay, to do that, again, naka-logarithm yung x coordinate natin, 0.250 minus logarithm at 0.150 over 41.60 minus 20.36. Between this value, natin mahanap yung the diameter at the 30% finer. Logarithm of 0.250 minus logarithm ng D30 over 41.60 minus 30% finer. So, kapag sinip-solve natin yan, makakuha tayo ng value na 0.189. Okay, for D10, dito natin mahanap sa value na to between this value. Okay, so again, logarithm of 0.150 minus logarithm of 0.075 over 20.36 minus 6.93 equals natin logarithm of 0.150 minus logarithm diameter at the 10% finer over 20.36 minus 10. D10 natin is equivalent to 0.088. Okay, ito yung second option kung paano natin kuhanin yung mga diameter on a specified percentage finer. So, method 1, using plot. Method 2, using interpolation. So, checking natin, kailangan yung value natin, since nag-interpolate tayo, kailangan between this value, doon natin mahanap yung hinahanap natin na specific diameter. Next, determine the value of CU or the uniformity coefficient or D60 over D10. Assuming na ito na lang yung gagamitin natin, 0.409 divided by D10 na 0.088, naka millimeter to, millimeter din, cancel yung unit. 0.409 divided by 0.088, 4.64. 4.64 for the uniformity coefficient. Coefficient of gradation D30 squared multiplied by D60 times D10, which is 0.189 squared over 0.409 times 0.088. Nakakuha tayo ng 0.189 divided by 0.409 times 0.088, 0.99 na sagot. Indeed, meron kakaroon tayo ng possible na iba't ibang sagot, pero hindi naman dapat siya at least nagkakalayo. Okay, so meron namang mga considerable variations naman since depende sa pagra-round up natin. Okay? So, ganun isolve yung problem number 1. For problem number 2, the grain size characteristics of a soil are given. So, given natin is size in terms of naka-millimeter na siya, 0.425, etc. And the corresponding percentage finer. So, ito yun na yung mga coordinates natin. Ito yung x, ito yung y coordinates. So, there's nothing to solve pa yung mga percentage finer since given na siya. Draw the grain size distribution curve. Determine the percentage of the gravel, sand, silt, and clay according to MIT. Ito naman yung USDA at saka in terms of AASHTO. So yung point lang ng problem na to is malaman kung ano-ano ba yung mga percentage finer base sa mga organization na consider natin. Okay. So, ano ba yung mga MIT? Ito yung sinasabi ko, pag greater than 2 mm gravel na yon, between 2 mm to 0.06 is sand, so on and so forth. Kaya kailangan kabisado natin itong particle size distribution table. Okay, so since given na yung ating coordinates, so ipa-plot na ngayon natin siya sa ating table. So after plotting, ganito lilitaw yung ating particle size distribution table. Okay, from 100 na 0.425, this is 0.1, 0.2, 0.3, 0.4, so 0.425. This is x 0.425 na 100%. Ito naman 90 na 0.33 na 90 yung kanyang coordinate. 0.018 para sa 80% finer. Next naman 0.01 para sa 70% finer. Ito naman 0.0062 para sa 60% finer. Tapos D50 na 0.0035 tapos 50% yung y coordinate, second to the last 0.0018 tapos yung kanyang y coordinate is 40, and lastly 0.001 tapos yung kanyang y coordinate is 35. Okay, so ito yung ating plot. So first, ito yung answer sa letter A, yung pagpa-plot ng particle size distribution curve or particle size distribution table natin. Next, solve naman daw natin kung ilang percent yung gravel, ilang percent yung sand, ilang percent yung silt, at saka ilang percent yung clay base sa MIT. So, for the sake of the discussion, pilat ko na yung mga increment or mga limits para sa MIT, para sa gravel, sand, and silt, and clay. So, recap. Para masabi natin na gravel siya sa MIT should be greater than 2 mm to 0.06 pag sand, silt naman 0.06 to 0.002, and less than 0.002 is considered as clay, which is indicated siya 0.2 onwards That is gravel. And 2 to 0.01, 0.02, 0.3, 0.4, 0.5, 0.2, 0.3, 0.4, 0.5, 0.6. So 0.06 to 0.2. So for the gravel again, zero point for gravel again greater than 2 millimeter, and for sand naman 2 millimeter to 0.06 millimeter. For silt naman, we have 0.06 to 0.002, and less than 0.002 is considered as clay. So ito yung kanilang mga limits. Bahin natin yung kulay. Ito yung mga boundary nila. Okay. So, ilan daw yung percent ng gravel, ilang percent yung sand, ilang percent yung silt. Okay. So, para hindi tayo malito, ulitin lang natin yung pag-coordinate. This one is 0.425 for the x-coordinate, tapos 100% yung ating coordinates. Second point, 0.033, tapos yung coordinate niya is 90% finer. Third, 0.018, tapos yung kanyang coordinate na 80%. Next, 0.01, tapos 70% yung kanyang finer. Para naman sa 60% finer, 0.0062, tapos 60% finer nga siya. Next, 0.0035, tapos yung kanyang percentage finer is 50%. Next, 0.0018 for the x-axis and 40% for the percentage finer. Last, 0.001, 0.001, tapos yung coordinate niya is 35. Ito yung ating coordinates. Okay. So, since unahin natin yung percentage ng gravel. So yung gravel natin, since hanggang dito lang ang ating plot or yung curve, so yung wala tayong gravel dito or 0%. 0% yung gravel base sa MIT. Next, percentage of sand o yung bahangin o yung fine aggregates. ilan lahat yung hanggang dito. Hanggang dito sa limits na to. Between 2 mm to 0.06. Dito, since mga percent finer yung or percent of gravel, sand, and silt, so magmamatter muna sa atin yung mga percentage finer. So in this case, nasa 100% tayo. So we just subtract 100 minus ilan tong value na ito. So base sa ating computation, so if this is 100 and this one is 80, sinit po, i-reflect ko lang. Ito yung ating 90% finer, nasa gitna siya. This is the 95%. Okay? That means 100 minus 95, that is, yung percent ng sand is 5% daw. Or 5%. Kumbaga, projection. So, next, percent of silt. So, yung silt natin is between this value hanggang dito sa ating limits. Yun daw yung ating silt. Or, ibig sabihin, 95% minus, this value is 95, ilan daw ito. So if this is kalahati, this is 50, kalahati is 45, 44, 43, 42, 41, so roughly this is at 42%. Ibig sabihin, 95 minus 42, that is roughly 53%. And lastly, percent of clay, less than 2 millimeter. Okay, so this value, this is 42 minus, this one is 35. Sorry, 42 minus 0%, so this is 42, tas hanggang dito 40 minus 0, that is 42. So 42 minus 0, that is 42. So kapag pinag-add natin yan, 42 plus 53 plus 42, that yields to 100%. Okay? So ganun yung pag-compute ng mga percentage ng mga gravel, sand, and silt, tsaka clay. Okay? Next, for USDA, ganun pa din. So, since USDA na yung ating kino-consider, gravel natin is same na, greater than 2 mm. Sand naman is 2 mm to 0.005. Sorry. 0.05 to 2 mm. For silt naman, 0.005 to 0.002, and less than 0.002 is considered as clay. So, dito natin, ganun din, same procedure. ilan ba yung nagpass or nagpasa or nagpass through sa gravel. Yung passing 2 mm, that is 0 for gravel. Okay, yung natira naman from sand, this is 100, o yung coordinate natin is 0.425, 100, tapos hanggang dito, this is 0.05. Okay, so what is this value? So this is roughly approximately 294. 94%. So ibig sabihin, yung lumagpas dito is 94%. For sand passing is 94%. Dito naman yung lumagpas dito is from ulit. Dito natin for percentage of gravel for USDA. Okay, ilan bang percentage of gravel? Okay, which is, since wala tayong, di umabot dito yung ating gravel, so that means 0% yung ating gravel. Next, for sand, percentage of sand, this is this value na 100%, and this one naman is roughly yields to 94. So kung po-project natin ito, ano to in short, so that is 100 minus 94. 100 minus 94, approximately 6% para sa sand. Para naman sa silt, so this is, if this is 94 and assuming this is 42, okay, 42 kamukha lang ng na-compute natin kanina. So kapag pinroject natin ito papunta dito, what is this value? Or we can say na 94 minus 42, ibig sabihin equals to 94 minus 42, that is 52. And percentage of clay, this is 42 minus 0, or 42 hanggang dito. Kaya siya 42 minus 0 or 42. So kapag pinag-add natin 6 plus 52 plus 42, that is yields to 100%. Ganun lang pag-compute for particle size distribution base sa iba't ibang mga organization.